The following edited narrated DVD will document Aquatic Inspection's wet inspection of Lake Reservoir No. 2 for the Lake Hemet Municipal Water District. Lake Reservoir No. 2 is a welded steel potable water storage facility located in Hemet, California. The reservoir is 32 feet high with a diameter of 104 feet. Lake Reservoir No. 2 has a storage capacity of 2 million gallons. The inspection was conducted on May 1, 2008. The paint on the steel exterior ladder and safety cage is in good condition. The ladder guard was securely padlocked at the start of the inspection. The ladder is securely welded to the shell or vertical walls. The target, located next to the ladder, was not functioning at the time of the inspection. The facility was erected on a concrete foundation or ring wall. The foundation or ring wall appears to be in good condition. Erosion is not present at the base of the facility. Lake Reservoir No. 2 has two round shell manways. The first manway, located near the base of the shell at approximately 1230, is in good condition without corrosion or water leakage. The manufacturer's nameplate is attached to the shell directly above the manway. Lake Reservoir No. 2 was erected in 1977 by Pittsburgh Des Moines Steel Company. The majority of the paint on the exterior of the shell or vertical walls is in extremely good condition. Chip paint, exposed primer, and light surface corrosion were observed in a few areas. The paint on the exterior of the shell is not chalky. The chip paint, exposed primer, and corrosion appear to be a result of vandals throwing rocks at the facility. This is a view of the second round shell manway, located at approximately 630. The manway is also in good condition without corrosion or water leakage. A hose bib sampling line exits the tank near the base of ring number 4 at approximately 11 o'clock. The line appears to be in good condition. This is a view of the 12-inch common inlet-outlet line. The majority of the paint on the exterior of the common line is in good condition. Minimal corrosion is located on the common inlet-outlet line. The facility was isolated during the inspection. The overflow line exits the reservoir near the top of ring number 1. The paint on the exterior of the line is in good condition. The overflow line is secured to the shell by 3 steel standoffs. The access hatch located on the roof was securely padlocked at the start of the inspection. The interior of the access hatch is coated with what appears to be super tank solution. The majority of the coating is in poor condition. Dense corrosion is located on a rafter near the access hatch. A slight oil film was observed floating on the water line. The majority of the paint on the safety railing is in good condition. Minimal corrosion is present. This is a view of where the target enters the facility. The majority of the paint on the exterior of the roof is in good condition. The paint is not chalky. Chip paint and light surface corrosion were observed in a couple of areas. A considerable amount of an unknown substance that could be bird fecal matter, insects, is located on the exterior of the roof of Lake Reservoir No. 2. The substance is easily removed with contact by the diver inspector. This is an example of chip paint and light surface corrosion on the exterior of the roof. One vent is located in the center of the roof. The vent screen is in good condition. Close-up of the vent screen. Another example of the substance that was found in many locations throughout the exterior of the roof. A couple of rocks thrown by vandals were also observed on the exterior of the roof. Graffiti is not present on the exterior of Lake Reservoir Number 2. A bolted access hatch is located on the roof at approximately 6 o'clock. The bolted access hatch is also securely padlocked and in good condition. In conclusion, the majority of the exterior of Lake Reservoir Number 2 is in extremely good condition. Water clarity on the interior of the facility was rated as good. The base of the ladder appears to be coated with coal tar enamel, with the remainder of the ladder coated with what appears to be super tank solution. The coating on the ladder and safety cage is in fair to poor condition. Coating failure has resulted in corrosion in many locations on the ladder and safety cage below the waterline. The ladder is securely welded to the shell. A few isolated coating blisters are located on the safety cage and ladder. The condition of the coating on the ladder appears to be similar to when we last inspected the facility approximately 5 years ago. The floor of Lake Reservoir Number 2 is coated with coal tar enamel. A small section of the floor directly in front of the common inlet-outlet line was free of sediment. The reservoir was isolated during the inspection. Note the debris on the floor directly beneath the common line. It appears that the gate valve is not completely closed. Note the slight void at the base of the gate valve. We recommend monitoring the corrosion located on the valve. A drain line exits the facility near the base of the steel interior ladder. The coating on the interior of the drain line appears to be in good condition. Obstructions are not present. The majority of the floor is covered with between 1/8 to 1/4 of an inch of sediment. This is a view of the base for the target. The guide wires are securely attached to the base of the target. The float for the target is hung up on the guide wires approximately 10 feet above the floor. This is a view of the round shell manway located at approximately 1230. The coal tar enamel on the manway is in fair condition. A few isolated coating blisters are located on the manway. The blisters have not ruptured. Ring number 4 is coated with coal tar enamel. The remainder of the shell is coated with what appears to be super tank solution. Isolated coating blisters were observed in many locations on ring number 4. The majority of the blisters have not ruptured. Example of coating failure on ring number 4. Note the many small pieces of a black substance on the floor. The black substance are pieces of failed coating from ring number 1 that have delaminated from the shell. This is another example of the condition of the coal tar enamel coating on ring number 4. Note the isolated coating blisters. The majority of the blisters have not ruptured. Close-up of the weld that connects ring number 3 with ring number 4. The majority of the coating at the transition from coal tar enamel to super tank solution is in good condition. Minimal corrosion is present at the transition. Another example of isolated coating blisters on ring number 4. We strongly recommend conducting 11-month warranty inspections after construction or recoating of water storage facilities. Coating defects can usually be identified during a warranty inspection. Another view of some of the sediment located on the floor. The bulk of the sediment consisted of extremely fine silt. Corrosion nodules were visible through the sediment in many locations. The diver attempts to remove a corrosion nodule to inspect for pitting. Many of the corrosion nodules on the floor are quite dense. The floor appeared to be slightly pitted. Another view of some of the sediment found on the floor. Indications of vandalism were not present on the interior of Lake Reservoir number 2. Indications of water leakage were not detected. An outer circle of 6 steel support columns and the center pole are located on the interior of the facility. The base plates are coated with coal tar enamel. All base plates were covered with sediment, which hindered the inspection of the condition of the coating. Approximately the lower 8 feet of the columns is coated with coal tar enamel, with the remainder of the columns coated with super tank solution. Isolated coating blisters were observed in a few areas near the base of the columns. The blisters have not ruptured. This is a view of the transition from coal tar enamel to super tank solution. The bulk of the coating at the transition is in good condition. Minimal corrosion is located on the columns below the waterline. Another view of some of the sediment found on the floor of the facility. The sediment on the floor hindered the inspection of the condition of the coating. The removal of the sediment would allow for a thorough inspection. Another example of isolated coating blisters on ring number 4. The condition of the coal tar enamel coating on ring number 4 appears to be in similar condition to when we last inspected the facility. The diver ruptures a coating blister to inspect for corrosion. Corrosion is not present. Delaminating coating is not present on ring number 4. Note the isolated coating blisters. Once again, the blisters have not ruptured. Another view of the transition from coal tar enamel to super tank solution. The bulk of the coating at the transition is in good condition. In a few areas, the coal tar enamel coating is losing flexibility and cracking on ring number 4. Light surface corrosion was observed in locations where the coal tar enamel coating has cracked. This is an example of the condition of the super tank coating on ring number 3. Minimal corrosion was observed during the inspection of the coating on ring number 3. The coating on ring number 3 appears to be in similar condition to when we last inspected the facility. Close-up of the weld that connects ring number 2 with ring number 3. The majority of the coating on the weld is in good condition. The condition of the super tank coating on ring number 2 is in fair to poor condition. The super tank coating on the upper half of ring number 2 is losing flexibility and cracking. Close-up of where the coating is losing flexibility and cracking near the base of ring number 2. The condition of the coating on ring number 2 deteriorates as the diver ascends. Light surface corrosion is present in locations where the super tank coating has lost flexibility and cracked. Corrosion is visible where the coating is cracked. Close-up of the weld that connects ring number 1 with ring number 2. The coating on the top half of ring number 2 and all of ring number 1 is in extremely poor condition. The coating is losing flexibility and cracking and delaminating from ring number 1 near the waterline in many areas. A slight oil film and surface scum was observed floating on the waterline of Lake Reservoir number 2. We suggest routinely overflowing the facility. This is a view of the second round shell manway. The manway is also coated with coal tar enamel. The bulk of the coating is in fair condition. Dense corrosion is located in many areas near the gasket for the manway. We recommend closely monitoring the corrosion located near the gasket for the manway at approximately 6:30. Close-up of the hinge for the manway. Another view of the sediment found on the floor. Example of a corrosion nodule visible through the sediment on the floor. The diver removes the sediment to inspect the corrosion nodule. Once again, the majority of the corrosion nodules on the floor are extremely dense and not easily removed with contact. The floor appears to be slightly pitted. Once again, the majority of the sediment located on the floor of Lake Reservoir number 2 is extremely fine silt. A slight accumulation of sand was observed on the floor near the common inlet-outlet line. The interior of Lake Reservoir number 2 was not cleaned at the conclusion of the inspection. This is a view of another base plate. Minimal corrosion was observed on the base plates. Few isolated coating blisters are located on base plates. Once again, the blisters have not ruptured. Minimal corrosion is located near the base of the columns. View of the transition from coal tar enamel to super tank solution, approximately 8 feet above the floor. The bulk of the super tank coating on the columns below the waterline appears to be in good condition. An example of a slight accumulation of sand on the floor. Corrosion nodules are visible through the sediment in a few areas. View of a base plate located near the common line. Coal tar enamel coating on the base plate appears to be in good condition. Another example of the condition of the coal tar enamel coating near the base of a column. Minimal corrosion is present. View of the transition from coal tar to super tank. Once again, the majority of the super tank coating on the columns below the waterline is in good condition. An example of corrosion nodules visible through the sediment on the floor. Another example of a corrosion nodule. Another example of a corrosion nodule visible through the sediment on the floor. Another view of corrosion nodules. The removal of the sediment will most likely reveal additional coating failures on the floor of Lake Reservoir number 2. Another example, coating failures on the floor. Note the many small pieces of super tank coating that have delaminated from the shell near the waterline. The condition of the coating on ring number 1 and ring number 2 has deteriorated since our last inspection. Corrosion was observed in many locations on the weld at the transition from shell to floor. The diver removes some of the sediment at the transition from shell to floor to inspect the condition of the coating. Another example of the condition of the coal tar enamel coating on ring number 4. Note the many isolated coating blisters. Some of the blisters are quite large in size. The blisters have not ruptured. Coating blisters are usually a result of poor preparation by the coating contractor. Close-up of the weld that connects ring number 3 with ring number 4. The bulk of the coating on the weld is in good condition. The bulk of the coating at the transition from coal tar enamel to super tank coating is also in good condition. Minimal corrosion is located on ring number 3. The condition of the super tank coating on the shell deteriorates on ring number 2. The super tank coating on all of ring number 1 and approximately the upper half of ring number 2 is losing flexibility and cracking. A considerable amount of air bubbles are clinging to the majority of ring number 2 and ring number 1. Corrosion was observed in many locations where the super tank coating on ring number 2 and ring number 1 has cracked. We recommend closely monitoring the condition of the coating on the interior of the facility. This is an example of the condition of the super tank coating on ring number 1 near the waterline. Delaminating coating was observed in many locations on the shell near the waterline. Slight contact by the diver inspector would dislodge pieces of the super tank coating. Note the poor condition of the coating on the shell near the waterline. Extensive coating delamination is present on ring number 1 near the waterline. This is a view of the overflow weir box. The overflow weir box is also coated with super tank solution. The coating is losing flexibility and cracking on the weir box. Light surface corrosion is present in locations where the coating is cracked on the weir box. View of the overflow weir box above the waterline. The bulk of the coating on the weir box is in poor condition. The roof structure of Lake Reservoir number 2 is coated with super tank solution. The majority of the super tank coating on the roof structure is in poor condition. Coating is losing flexibility and cracking and delaminating in many areas on rafters, ring girders, tie rods, and roof plates. All rafters appear to be securely bolted to rafter clips. Note where the coating is losing flexibility and cracking on roof plates near the shell. Twisted or bowed rafters were not observed. An example where the coating is losing flexibility and cracking at the base of a rafter. Super tank coating is also losing flexibility and cracking in a few areas on columns above the waterline. Close-up of a ring girder. Coating is also losing flexibility and cracking in many areas on ring girders. Blistered coating was not observed during the inspection of the roof structure. View of the hat plate. The super tank coating on the hat plate is also losing flexibility and cracking. Light surface corrosion is located in areas where the super tank coating has cracked on the hat plate. Close-up of the center pole above the waterline. All rafters appeared to be securely bolted to the hat plate. View of a tie rod. Close-up of a ring girder. Coating failure has resulted in corrosion in many areas on ring girders. Close-up of a column above the waterline. All ring girders appear to be securely bolted to columns. Another example where the coating on a ring girder is losing flexibility and cracking. In conclusion, with the majority of the super tank coating on the roof structure, ring number 1 and ring number 2 in poor condition, we recommend that consideration be given to recoating the interior of Lake Reservoir number 2 with epoxy in the near future. Another example of where the coating on roof plates is losing flexibility and cracking. Until the facility can be recoated, we recommend closely monitoring the condition of the coating on the interior of the facility. This concludes Aquatic Inspection's wet inspection of Lake Reservoir number 2. We would like to thank the Lake Hemet Municipal Water District for retaining our services. If there are any questions about the inspection of Lake Reservoir number 2, don't hesitate to contact Aquatic Inspections at 760-753-4812.